I see you again. So today we will go to this trigonometric ratio, chapters, right? So first thing for today, we will look at in this trigonometry triangle. So the triangle must be a right angle triangle. So what is a right angle triangle? It's a 90-degree triangle. So now, when you are given an angle here, this one we call theta. Okay, theta is the symbol of the angle for angle. Alright, so the side, this one is the opposite side. The side opposite your theta angle is called as opposite. So the angle, the side that is next to the theta angle is adjacent. So how about the hypotenuse? Hypotenuse is the longest side of your right angle triangle and it will be opposite your right angle. So in this trigonometry, three things that we must know is that we will need to know what is tangent, what is cos, and what is sine. So to find sine theta is when we get the opposite over hypotenuse, and cos theta is adjacent over hypotenuse, and then tangent theta will be opposite over adjacent. So now, if let's say we look at this, very hard to remember. So we actually have an easier way for us to remember. So for sine, we can come up with this. So, cos CAH, tangent TOA. So we have this cancel. So you can see O for opposite, A for adjacent, H for hypotenuse, and here O for opposite, H for hypotenuse. Alright, so how are we going to find the trigonometric ratio for each of the angle here? So we look at the first one as our examples. So number one, the sine theta. So where is the opposite? Sine theta opposite is ST. So ST over your hypotenuse RT. So we have 15 over 17. So how about your cos theta? So cos theta is the adjacent. So adjacent of this is RS. So over RT. So RS over RT is 8 over 17. Whereas for tangent theta will be opposite, which is the ST over RS, the adjacent. So we will have 15 over 8. So we try another examples here. So if let's say now your theta is over here, you are asked to find sine, cos. When some of the side value is not given, we need to find the side. How are we going to find the side first? So to find JL, we use Pythagoras theorem. If let's say you forgot what is Pythagoras theorem, so that one was in Form 1, Pythagoras theorem chapters. So we have this side. Set of 39, we square it, plus 5 square. And then we square it the whole thing. So we will get 39 plus 25. 39 plus 25, we get 64. Square root of 64, we get 8. So your JL here is at centimeter. So now with that, we can find our sine theta, cos theta, and also tangent theta. So your sine theta here, okay, opposite over adjacent. So your sine theta opposite is 5 centimeter, okay, and then your edges, your hypotenuse is at, all right, and then your cos theta is the adjacent over the hypotenuse, which is at, and your tangent theta is opposite, which is 5, okay, and then, okay, adjacent, sort of 39. Very easy to find our trigonometric ratio. So let us try some more examples. Okay, so you are given a sine theta equals to P over Q. Okay, so express cos theta and tan theta in terms of P and Q. So when we have questions like this, okay, let us draw a right angle triangle first. When you draw, you will see, right? You can see the whole picture. So our theta over here, so sin theta is opposite over hypotenuse. So since you are asked to find cos theta and tangent theta, which need adjacent value, right? So we find our value over here first. To find the value for this side, it will be q squared minus p squared, and then we square root it. This one is Pythagoras theorem. So to find our cos theta, so cos theta is the adjacent over the hypotenuse. Okay, so we will have q squared minus p squared, and then we square root it. Okay, and then over your hypotenuse, which is q. And whereas for your tangent theta opposite over adjacent, so p over root, okay, square root q squared minus p squared. So very simple, very straightforward. So next, okay, we will have some words questions which you will normally get. Okay, so given tangent x equals to 0.75, okay, so you need asked to find the value of cos x and also tangent y. So before we can find that, we need to find the side value first. So what you are given here is only 6 centimeter, okay, and you are also given tangent x 0.75. So what we can do here, okay, so we find the side by using the ratio 0.75 first. So 0.75, okay, we change into a fraction form. So we have this as 3 over 4. So 3 over 4, your tangent x equals to 3 over 4. All right, so here is 3. This whole stretch here is 4. So we can see here 6, okay, 3, you get 6. So 4, this one, the whole thing will be at centimeter. So this whole thing is at centimeter, right? Okay, so now what they want you to find? Cos x. Okay, cos x, they want you to find the hypotenuse as well. So the next thing we need to find our hypotenuse, TQ. To find our hypotenuse, x squared plus 6 squared, and then we square root it. So x squared, 64 plus 36, add up together, we will get 100. Okay, and then we square root it, we get 10 centimeter. So your TQ whole stretch is 10 centimeter. Now we can find your cos. So your cos x, okay, the adjacent is at, okay, and then your hypotenuse is 10. Okay, remember we are not done yet. Okay, we cannot leave our answer and simplify. So let us simplify this. So we will get 4 over 5. Okay. So next we have tangent y. So how do we find tangent y? Let's see over here. Your y is over here. So you are given this whole stretch is 6. So you will have 3, 3. So now where is this PQ? PQ is 4 centimeter because 8 divided by 2. So your tangent y, okay, opposite 4. Then your adjacent is 3. Okay. So that's all for today. So in next video, okay, we will go to the second part of trigonometric ratio. Bye bye. I see you again next video.